Hi! In my last video I mentioned that I'm planning to bring back to life one of my old projects, and now is the time I can finally say, ladies and gentlemen, let me present you my new build. Maybe a few words to explain why I'm so happy about it. Well, comparing to previous version, I managed to improve a lot of things, which I will briefly discuss in a few moments, because the most important upgrade, and the actual goal of this project, was to check if it's possible to make it accessible and controllable over the internet connection. And I can gladly announce that I'm really happy with the outcome of this experiment. I'm using mobile data from my phone right now, so I'm definitely not in the same network as my robot, but still it's not a problem to establish connection. Just a moment for a camera to start up, and we have visual. Of course, frame rate is not as high as from within the local network, but that was to be expected. It's always something for something. But honestly, that doesn't hurt much. Overall experience is still pretty much real time. I have no problem to drive and look around simultaneously. It's also not a big deal to maneuver in the snow to make my robot go the proper path. Even though it's a tracked vehicle, it's still sort of a toy, and it's quite heavy like for its size, so if I go where the snow is too deep, I can get stuck pretty easy. Cool, I managed to reach the hard surface. Okay, hard surface is pretty boring. Let's see how difficult it will be to go back. Honestly, not difficult at all. Okay, still there is some latency, so probably I wouldn't dare to drive a race car with this technology. But let's say it straight, this vehicle was never meant to be a speed demon, so for this build it's totally fine, I can live with that. So overall, I consider this test drive a full success. Okay, we live in times when I guess everyone tried some sort of video chat already, so at this point you may ask, what's the big deal? Technology for real-time video transmission is readily available. Just add a little automation and some data channel to send commands to the robot, and job done, right? Well, not quite. Actually, not at all. If you ever participated in such video call, for sure you noted that there is some few seconds delay between the moment you do something, for example stop talking, and the moment the other participants react to your action. In short, it is so because internet is an unpredictable network. Whenever you send something over the internet, the message will eventually reach its recipient, but you can't tell precisely how long it's gonna take. So if you send a continuous stream of data, some packets will arrive quickly, while the other ones might be a bit late. In other words, to provide a smooth video playback that is well synchronized with sound, you need to play it from some sort of buffer. And that's the main reason why all the communicators have this few seconds delay. They just assume that such a tiny shift in time is nothing comparing to the benefits of having a stable, high quality video. And okay, if you want to have a conversation, this is a very good assumption. The problem is, I'm not going to conversate with my robot. I'm about to drive it. And in such contexts, this few seconds delay becomes eternity. Just imagine what would happen if a steering wheel in your car had, let's say, 3 seconds delay. So I made a different assumption. Let's forget about buffering and just burst frames straight into the screen as soon as they arrive. And you know what? That really works. Of course, playback is not as smooth as with buffering. I also had to reduce the resolution to standard definition, but this time those are acceptable costs of having as real-time experience as possible. As you probably can imagine, those are not the only complexities related with internet connectivity that I had to overcome to finally have my thing working. So at this point you may wonder, wouldn't it be easier to just use radio communication like drones do? Well, sure it would, but such approach has its downsides as well. The most important one is range. For hobbyist drones, range limit is usually not more than a few kilometers, but they operate in the air where there are not many obstacles between transmitter and receiver, so for ground drone, the effective range would probably be even smaller. With internet connection, the actual distance between devices is pretty much irrelevant as long as both of them have a good internet connection. And nowadays, internet access is something nearly as common as electricity, so in most cases, that should not be a problem. Additionally, most of devices can utilize this path of communication out of the box, without buying any specialized radio equipment, so for me, the advantages seems worth some extra effort. But you can check it yourself if you like. My software is open source, so you can use it in your robot too. In a moment I'll show you how to set up such project, but first let me just show you what it can do. First of all, user interface works in web browser, so you can use it on your laptop or PC, as well as on mobile devices without installing any additional software. You can move the head by dragging on the right panel. Double click will bring the head into center position. Moving chassis happens either using WSAD keys on the keyboard if you have one, or by dragging on the left panel. Here you can also find some information on current CPU temperature, Wi-Fi signal and frame rate, as well as some control buttons to enter full screen mode, close left panel if you don't need it, or switch on the light. Pretty straightforward, I guess. To connect your robot from outside a local network, just have a look on this video. Here I explain in details on how this feature works and how to set it up. All the necessary software is available on Stargate system page under Do It Yourself section. Package contains modified version of local server, program for robot and some STL models if you would like to print the same head I'm using. All links in description, and if you have any questions, feel free to ask them in a comment under any of my videos. And if you like some more information on how the program works and how to customize it, just let me know in the comments. I can make a separate video about it. Okay, but what about hardware? My build is using Raspberry Pi 3 Model A along with such cheap wide-angle camera. I still have a lot of space inside the head compartment to accommodate all the wires and a micro-sized servo used to move the head up and down. Another micro-servo is bolted down to the chassis. Power delivery and communication with the chassis happens through this 7-core wire. Quite a progress comparing to what was going on with previous version. Power supply also got improved. Previously I've been using such power bank for this purpose. But this time I decided that I want something bigger. and it works absolutely great. It has no problem to deliver sufficient amount of power to all the receivers from a single USB port, and it lasts for around 2 days of standby operation, which is totally sufficient for my current needs. The only downside is that there was not enough space inside the chassis to accommodate it, so I had to replace the original bottom plate with a custom one. But that's the minor issue. On the side, I mounted a flashlight operated by a transistor. In case you have no idea on how to use such weird semiconductor with Raspberry Pi, I have a separate video about it here on my channel. Just have a look in description. Okay, flashlight might be practical, but it's also pretty boring, so I made it in such a way that it can be easily replaced with some other module. And I have a lot of ideas on what else can be attached to such robot. But that's subject for the future. So hit subscribe button if you like such content, and see you on other videos.